and welcome to another math tutorial. Here's another question on advanced trigonometry. The question reads, the triangle ABC is right angled at C. The bisector of angle C meets AB at D. Now we are asked to prove that side CD equals to the product of radical 2 C sin B divided by 1 plus tan B. Now, the first thing we need to do is to draw the right angled triangle. And we also know that the angle 90 degrees, which is a right angle, okay, is at C. So that means we first draw a right angle triangle to analyze the problem, okay? Now at C is angle 90 degrees. So this is 90 degrees, okay? Now let's say this is A and this is B. All right, now the sides. So opposite B will be lowercase letter B. Opposite C will be represented with what? Lowercase letter C. Opposite A will be represented with lowercase letter A. All right, now the bisector of angle C meets AB at D. Okay, so if we bisect this angle, okay, if we bisect this angle, that is when the angle is divided into two, okay, the line, okay, the bisector, okay, meets AB at D. That's it. All right, so that means that we're going to have this angle BCD to be 45 degrees, then angle ACD to be what? 45 degrees. So that means we now have two triangles in this triangle. All right. So the first thing we're going to do is, okay, now let's do it this way. Okay, so I'm going to start with any one of the two triangles. So now by considering triangle BCD, so we have that I'm going to applying the sine rule, okay, to triangle BCD. So we have that in this case we're going to have CD, okay, divided by sine B, because CD is opposite angle B. Then that will be equals to, then also we have DB, okay, divided by BCD, that is sine BCD. And let's not forget that angle BCD is equals to angle ACD, and both are equals to what? 45 degrees. That's it. All right. Now, BCD is 45 degrees. So which means we can say from here, CD over sine B equals to DB over sine 45 degrees. So that means we're going to have sine 45 degrees. So that CD can be equals to DB multiplied by sine B divided by, now sine 45 degrees will be 1 over radical 2, okay? So that CD will be equals to the product of radical 2, then DB and sine B. So let's call this equation 1. This is our equation 1. All right. Then again, let's consider triangle ACD. Now, considering triangle ACD. So we have that by applying the sine rule, to triangle ACD. So that means in this case, we then have CD. Of course, we can see that CD is obviously the side opposite angle at A. So we have CD divided by sine A, and that is equals to then this side AD, okay, divided by sine ACD, and we know that ACD is what? 45 degrees, okay? So that this will be CD equals to AD, okay, times sine A divided by sine 45 degrees. And again, we know that sine 45 degrees is 1 over radical 2. So in this case, we're going to have CD to be equals to AD sine A over 1 over what? Root 2. So that CD will be equals to root 2 times AD sine A. And this is the second equation. That's equation 2. All right, so now we can use any one of these two equations to prove this identity. We can use any one of the two equations. But there's another thing we need to put into consideration. Now we have a bisector, okay? So there's what we call the angle bisector theorem, which states that, okay, which states that the angle bisector, okay, will divide the side, okay, the side of a triangle into two segments, okay, that are, that are proportional to each other. I think that's the theorem. Yes, that's the angle bisector theorem. That is, the angle bisector will divide the side of a triangle into two segments. That is, the length of, that is, this will be equals to this, okay? So according to the theorem, okay, we can then, now because we know that AC, okay, let's, now, so by applying, okay, by applying the angle bisector theorem, angle bisector theorem, okay, angle bisector theorem, which states that, like I said, the angle bisector divides the side of the triangle into two segments, okay, into two segments that are, that are proportional to what? To the other two sides. Yes, the other two sides. All right. So in this case, so according to the theorem, we're going to have AB divided by BC. Okay, AB. Okay, the two legs of the right angle triangle, AB, okay, AC, okay, AC divided by BC, okay, that will be equals to, because this is a what? This line bisect this side into two. So we're going to have AD, okay, AD divided by DB, AD divided by DB. And we can see from here that AC, okay, is B, lowercase letter b, okay, and then BC is what? Is A. So which tells us that if you want to find AD, according to the theorem, AD, now for AD will be the product of B and C, okay, BC divided by A plus B. Then for DB, because like I said, we can use any one of these two equations to prove, to prove that the side CD equals to this. All right. So for DB will be, that's for DB, that will be, DB will be equals to, that's going to be AC, product of AC divided by A plus B. Yeah, that's it. All right. So now, so we are going to, then also, let's look at the triangle. We have again here that if we consider that an angle is given at B, okay, so the sine of angle at B, we know sine B will be opposite, okay, the sine of angle at B, that will be opposite over what? Hypotenuse. And that will be, the opposite will be B, while the hypotenuse will be C. Let's take note of that. So we can say that sine B equals to B over C. Then also, tan of this angle, tan, okay, tangent, tan of angle at B, that will be opposite over adjacent. We have opposite over adjacent, and that will be B over A. All right. Okay. So now, so the next thing to do is, now let's use one of the equations. So we have that from equation 1, we have that CD is equals to radical 2 multiplied by dB, okay, then sine B. Now, then we have here that dB is equals to AC divided by A plus B. So that means CD will be equals to radical 2 multiplied by dB, which is what? AC over A plus B. Then multiply by sine B. Multiply by sine B. That makes sense. All right. So, okay. So now, let's also forget that sine B is what? B over C. So we can say CD equals to radical 2 multiplied by AC divided by A plus B multiplied by, so sine B, which is what? B over C. So C will cancel C. So that CD can be equals to, so we're going to have root 2 times A multiplied by B divided by A plus B. Now again, we have here that tan B equals to B over A. Okay, tan B is equals to B over A. So which means we can say that tan B, so if I make B the subject of the formula, or I make A the subject of the formula, okay, we're gonna have tan, okay, so from here we have CD to be equals to root 2 multiplied by A, which is, if I make A the subject formula, that will be B over tan B, okay, B over tan B multiplied by B, okay, divided by, now, if I make A the subject of the formula, in this case, we're going to have B over tan B, B over tan B. Yeah, that's B over tan B, then plus B. So let me bring this here. So what we have now is CD equals to root 2 multiplied by B times B, that will be B squared, then divided by tan B all over. Now, let's not forget that this will be the numerator. Okay, then we have B over tan B plus B over 1. Anyways, okay, so this is the denominator. All right, now let's factor out B in the word denominator because it is common. So we can have CD to be equals to B squared, okay, multiplied by radical 2 over tan B divided by, so if I bring B out, this will be 1 over tan B plus 1. All right, so in this case, so B will cancel what? B, we have B remaining. So we have CD to be equals to, so now if we simplify this, this is going to be root 2 over tan B multiplied by, simplification of this will be tan B times 1, that will be tan B. So we have 1 plus tan B, okay? So we have 1 plus tan B. Okay, let me write that. We have 1 plus tan B. Let's not forget that we still have B here over tan B, over tan B. So we have two fractions, okay? This dividing this. All right, so that CD will be equals to, so this will flip. We have root 2 times B over tan B multiplied by tan B divided by 1 plus tan B. Okay, okay, all right. So now, so in this case, we can say tan B cancel what? Tan B, so that we can have CD to be equals to B root 2 divided by 1 plus tan B. Now let's recall. Now we have from here, let's recall, we know that sine B is equals to B over C. So that means that C will be equals to B over sine B. Okay, that will be equals to B over sine B. So I'm going to what? I'm going to represent, okay, we have sine B. Okay, let's make B the subject of the formula. All right, So in this case, we're going to have B to be equals to C sine B, from sine B equals to B over C. So we have that. Let me write this again. Okay, we have B to be equals to C sine B. Okay, C sine B. So we put that here. So we have CD to be equals to, so B is now C sine B, then multiply by radical 2 over 1 plus tan B. So therefore, CD will be equals to, okay, we can write C radical 2 sine B divided by 1 plus tan B. And we just prove that side CD, okay, is equals to the product of C radical 2 sine B divided by 1 plus tan B. The noblest pleasure is the joy of understanding. Bye-bye.